This one is 16.6, number 9. Once again, we're finding the area of this function right here, except this time it's limited inside of this cylinder. So the cylinder is x squared plus y squared equals a squared, so it's a cylinder of radius a centered at the origin. It's as high as it needs to be to intersect with this, and of course we just want the surface area of that inside of it. Well, once again, we're looking to parameterize, and this time we'll take the easy way out because this function doesn't lend itself well to being represented in any other way. We'll just use sort of the default, which is r is equal to u v, and then u squared minus v squared. Okay, that makes ru equal to 1, 0, 2u, and then our v is equal to 0, 1, negative 2v. And the cross product, ru crossed with rv, is going to be equal to, the ith component is nothing minus 2u. The jth component is negative 2v, so that's 2v. And the kth component is just 1. And that means its magnitude, ru crossed with rv. Magnitude is going to be 4u squared plus 4v squared plus 1 under the radical. And at this point, it's pretty clear that this would be best done in polar coordinates. So that's actually how I'm going to do it. I'm going to say that u is equal to r cosine of theta, and v is equal to r sine of theta. And that means the argument right here for our integral is just going to be 4r squared plus 1 under the radical. So we'll have the double integral. Theta is going to go from 0 to 2 pi. R is going to go from 0 to a. And then we'll have the square root of 4r squared plus 1. And before you think this will get hard, keep in mind that we've converted into polar coordinates, which means our dA, which comes with the integral. Remember, we're doing double integral of ru cross rv magnitude dA. Our dA integral in polar coordinates is r dr d theta. So that brings an extra r with it, r dr d theta. So that makes the u sub pretty easy. As a matter of fact, when we finish with this integral, we get pi over 6 times the quantity 4a squared plus 1 to the 3 halves minus 1. And again, that is the surface area of that inside of this cylinder.